Namaste everyone. Hope all of you are well. With a refreshment that we are going to start our second part of chemistry. Second part of chemistry with some basic concepts of redox reaction as we have discussed in 10th standard also. There was one reaction in 10th standard as I have remembered, especially in first chapter I think, that copper plus oxygen cuprous oxide CuO. And as you know very well that how in that reaction the reduction and oxidation both were shown. Many of the students may have remembered or may not. Just let me show you that in the 10th standard how you know about that reaction, that it was a redox reaction. First of all, let me say you what is redox reaction. Redox, the word redox reaction say here RED stands for reduction and OX stands for oxidation. A reaction in which reduction and oxidation both are present, that type of chemical reaction is known as redox reaction. How, as I have said you, in the 10th standard there was one reaction Cu plus O2 CuO. If you want to balance this reaction, then you can just write like here 2Cu plus O, that is 2CuO. It's a cuprous reaction. There are two types of oxides of copper, cuprous oxide and cupric oxide. The minimum valency or minimum oxidation states are called cuprous and maximum means, just remember your students, plus 2 and minus 2 and plus 1, cuprous and cupric. Let's show you first of all how this reaction is a redox reaction. As this thing you have studied in class 10, if you have remembered the first chapter chemical reaction, in that chapter only this reaction was there. See here, these are the neutral molecules, the oxidation states of these are 0. As this is the cuprous oxide, so plus 2 and minus 2. You can see here from 0 to plus 2. As the oxidation state increases, you know very well how the oxidation state will increase by losing an electron. So here from 0 to plus 2 means it has to lose 2 electrons. So this is called oxidation. What is called? Oxidation. And it was 0 to minus 2 means it has reduced its oxidation state. So it is called reduction. So here you can see in this reaction, both the reaction was there and it was known as redox reaction. This was the example of redox reaction in 10th standard. If you have remembered of 10th standard words, then only you can think also and you can see also that really what is redox reaction. Right? The rest of the things that you have learned in the 10th standard, that addition of oxygen. Right? Addition of oxygen. What is oxidation? First I am saying you. Okay? Addition of oxygen. Second, removal of hydrogen. Correct? Here you can see as two things which is very compulsory, that addition of oxygen and removal of hydrogen. Addition of an electronegative element. Addition of an electronegative element. Remember this word. Addition of an electronegative element. Removal of an electropositive element. And the last one is loss of electrons. So the things which I have mentioned in oxidation, the just opposite in reduction. What happens in reduction, you know? In reduction, that is addition of hydrogen. Second thing, removal of oxygen. Third thing, as I have mentioned that addition of an electropositive element. So here there will be removal of an electronegative element. Sorry, addition of an electronegative element. Here you can see it is in the oxidation. So here it will be a removal of electronegative element. Electronegative element. And in the oxidation it is removal of an electropositive element. So here addition of electropositive element. And the last one, there is loss of electron. Here it will be gain of electron. Gain of electrons. So here you can see it is a very nice diagram in which you can say here that this is the difference between the reduction and oxidation. It is an introduction part, so no need to worry. First of all, whenever you learn something, that time you must have a curiosity. Why I start from basic, you know? Because the things which you have remembered in the 10th standard should not get forgotten from your mind. The reason behind it is that basic concept means what? Whatever the things you have learned in the previous standards, that previous standards extended form is called the main thing. Previous standard extended form. In the previous standard, these are all the things already you have learned. Now the thing is what? How you will remember this oxidation state. The question is that, as I have said you, what is oxidation state and what is valency? Valency is the combining capacity of an element. You have learned this whole define. The combining capacity of an element is called valency. But have you ever thought what is this combining capacity? Sodium do not combine one electron, sodium lose one electron, then why its valency is 1, etc., etc. Many things. Sometimes the question should come in your mind. If you do not remember the question, then remember your students, you are nothing. Question should arise in your mind that really, whatever the things which we have learned in the previous standard, is it true or false? Now I am saying with your student, first of all, valency, as you have learned in the previous standard about the valency, that combining capacity of an element. And as I have said, for what purpose they combine? Question is that either removal or addition, losing or gaining, to complete its octet, in the last cell. If it removes one electron and completes 8 electrons in its last cell, then that 1 electron will be its valence. As you can see in the sodium has 1 electron in its last orbit, in the third orbit. In the first orbit 2 electrons, in the second orbit 8 electrons, in the third orbit 1 electron. So what do this sodium do? Sodium removes 1 electron. As the sodium removes 1 electron, what will happen? It will complete its octet in the second cell. So this removal of 1 electron also. Why removal of electron? To complete its octet in the last orbit, last cell. So that is called valency. And what is the oxidation state? If I talk about this oxidation state, then remember, dear student, oxidation state means whatever the electrons it has in its last cell, whatever the electrons it accommodates in the last cell, accommodate means gain in the last cell. So that is its oxidation state. As for example, if I talk about oxygen, just think about the oxygen. What is the atomic number of this oxygen? Can you tell me? Oxygen atomic number is 8. Its electronic configuration is 1s2, 2s2, 2p4. So what will happen? In the last cell, if it takes 2 electrons, then it will complete its second cell orbit. In the first cell, you can see here, in the first cell, oxygen has 2 electrons. And in the second cell, 2 of S and 4 of P. 1, 2, 3, 4. So in the last cell, it is having 6 electrons. So how many electrons oxygen will take? So 2 electrons, if oxygen, it takes 2 electrons. 2 electrons means minus 2. It is taking 2 electrons, gaining 2 electrons, then its valence is minus 2. Okay? It will take 2 electrons, so that's why here minus. Whenever we borrow money from anybody else, then that part is called, we are credited. Means we are borrowed from that person. We have to pay. We have to pay that person that much rupees. That is our credit thing. When you go in the commerce field, if your brother or sister is studying account, then you can ask him, brother or sister, what is the meaning of debited and what is the meaning of credited? Credit, they know very well in the account, there is one word, debit and credit. Very nice word, especially I have heard from the commerce students. A person who takes money and who gives money, that is, means I am in loss. From my side the money has gone and from any person has taken that money, debited from that person and credited to that person. Credited. He has taken a loan or whatsoever. Similarly here, oxygen is taking 2 electrons. So why it's taking 2 electrons? Because to complete its octet in the last cell. If any elements do not give 2 electrons to the oxygen, now what will happen? Now oxygen will start losing one by one its own electrons. Means it was trying to take minus 2 electrons to complete its octet. If none of the element is giving a single electron to the oxygen, oxygen will start removing. First it will remove one electron, try to take one electron also. It's not giving one electron, then it will remove that. Then it will come in 0 oxidation state. Then it will come in +1 oxidation state, means it has removed 2p4th electron. Then it has removed 2p3rd electrons. Then it has removed 2p2nd electrons. Then it has removed 2p1th electron. Then it has removed 2s2 electrons. Then it has removed 2s1 electrons. Means slowly it has removed all the electrons from the second cell and it has completed duet in the first orbit. Why? Because each and every element has tendency to complete its octet in the outermost cell. You know very well. If it can't complete its octet, then they will try to go to the nearby what we see to that the last group element, that 0 group elements. They will try to attain the nearest electronic configuration of the inert group. So here, if it is not able to attain neon electronic configuration, then oxygen will try to attain helium electronic configuration. Now what I am saying to you, see, there are maximum businessmen in this world. Maximum. Mukesh Ambani, Lakshmi Mittal, you have heard these all the names. Some of the person have taken money from country and gone to another country like Vijay Mallya and many more. Now what I want to say you here is that each and every person can't become successful in their business. So if they do not reach to that level, then what they will previous to that level. As for example, just suppose a student is there. He is doing very hard work to crack IIT, JEE and advanced board exam. He had done a very hard study. After doing a very hard study, he had attained the exam IIT mains. He has got successful. After then advanced level, he has not got successful. So what will happen? He will not get the circle of IIT. He will not get the circle of IIT college or NIT college. So, but nearby, next to IIT and NIT, whatever the colleges are present in India, in that college he can get admission. Now you have understood what I want to say. I want to say that if can't complete this oxygen can't complete its octet in its outermost shell, then what? Oxygen will remove its electron and complete duet in its first orbit to attain helium gas configuration. So here from -2 to +6, these are the oxidation states of oxygen. Oxidation states, it is a variable valency. You can see from -2 to +6. A person has something to lose now. If you will not have something, then how you will lose? Are you understanding what I mean to say? It was having 6 electrons in its outermost shell. Yeah, it was very close that it should get 2 electrons and it should complete its octet. But if it is not getting, then what the oxygen will do? भाई अगर आईआईटी कॉलेज में एडमिशन नहीं मिलेगा तो किसी और कॉलेज में लेकर के भी तो बीटेक तो करोगे ना. Are you understanding? Now similarly here also, if it is not getting 8 electrons in its outermost shell, then it will try to gain helium configuration by removing its electron from the outermost shell. So as you can see, -2 to +6, these are the oxidation states of oxygen. Similarly of any elements, if you want to calculate the oxidation state, then they have to remove that electrons from their outermost shell till whatever the last electron was having in that cell. That is its oxidation state. In the whole periodic table, the maximum oxidation state is +8. 8 से ज़्यादा इलेक्ट्रॉन कोई नहीं निकाल सकता. क्यों पता है? लास्ट सेल में 8 इलेक्ट्रॉन होते हैं. So that's why you have to understand this basic concept. Now one thing which I want to say you is atomicity. Have you heard the word atomicity? The meaning of this word atomicity is the element which exists in the nature by attaining 1, 2, 3, 4, 5 atoms. कहने का मतलब, if I talk about oxygen, if I talk about phosphorus, if I talk about sulfur, sulfur exists in the S8 form. If you talk about sulfur, then sulfur exists in the S8 form. Oxygen exists in the O2 form. Phosphorus exists in the P4 form. So these are the atomicity of the sulfur will be 8. Atomicity of oxygen is 2. Atomicity of phosphorus is 4. So when they are existing in nature, they are in the neutral form. So if anybody will ask you what is the valency of this element, then remember dear student, the valency of this element is 0. You can say if it is existing in a molecular form. Molecular form is existing form in the nature, then its valency will be 0. That most important thing you should remember in your life. If I talk about hydrogen, can you tell me what will be the atomicity of hydrogen? Hydrogen atomicity H2. Hydrogen exists in the H2 form in the nature. So the H2 is a molecular form. So that's why here the oxidation state of these elements will be 0. So oxidation state of all the elements in their elemental form. Elemental form is standard state is taken as 0. So here you can see Cl2, F2, O2, P4, O3, Fe, H2, N2, C. These all are existing in the 0 oxidation state. Common oxidation state of element of group 1 is 1. Common oxidation state of group number 2 is 2. Common oxidation of group number 3 is 3 and 1. Common oxidation states of group number 4 is 4 and 2. Common oxidation states of group number 5 is 3. Similarly, group number 6, 2. Group number 7, 1. And group number 8, 0. So these are the common oxidation state of these group elements. Okay? Now, as if you want to calculate any element's oxidation state or oxidation number in any form, if I talk about hydrogen peroxide. Have you heard the word hydrogen peroxide? Have you heard peroxide? Peroxide means peroxide. H2O2. This is the formula of hydrogen peroxide. If you want this compound, you can just go into the medical store and you can just ask to the chemist or pharmacist, please provide me hydrogen. So they will provide you one water bottle. It is a Ganga Jal type bottle. It will cost 15 to 20 rupees of 100 ml. This is antibacterial water. When you put this water in any wound spot, then that fungus, you can say that fungus die from that part, or it protects from the fungus and the dust outside, especially when ENT specialist clean your ears, that time they use this water, H2O2, hydrogen peroxide or peroxide. If I will ask you what is the oxidation state or valency or oxidation number of oxygen in this number, can you tell me? Similarly, NH2O2, if I ask anyone, the student will be very much confused. Generally, what do the students do? Students write here and means cation and here anion. So if they know whatever the number here is there and whatever the number here. So here this is the valency of this part and this is the valency of this part. Generally we do across verification, just like aluminum oxide, aluminum and oxygen. So valency of oxygen is 2 and aluminum is 3. So the compound will be Al2O3. Generally we write like this. But here what you will say? The oxygen valency 2 and hydrogen valency 2. No, dear students. Here both are existing in +1 oxidation state. How this is, hydrogen peroxide? Its structure is oxygen is linked with oxygen and oxygen is linked with hydrogen. This is the open book system. The structure of this compound is open book system. So you can see here. Here it is existing in -1, here also -1, here +1 and here +1. So you can see total -1 oxidation state of oxygen in this hydrogen peroxide. So the most important thing which you remember that how to calculate, because now you are not a small kid, right? There are so many types of oxygen, like oxygen main compound, most compound is -2. Peroxide exists in -1 oxidation number or oxidation state. Superoxide exists in -1/2 or N-oxidation state, you can say. Oxygen fluoride. Have you heard the word oxygen fluoride? OF2. OF2 and O2F2. Have you heard the word? Oxygen fluoride. So here, what will be because fluorine is highly electronegative element and more electronegative than oxygen also. So can you tell me what will be the oxidation state of oxygen and fluorine in this compound? See, these are the few compounds in which you generally think that sir is making us confusion, right? No need to be confused. Remember, dear student, here the oxidation number of oxygen is +2, not -2, because we have seen here this O2 is of this oxygen and here 1 is of fluorine. So here the oxidation number of oxygen is +2, and if I talk about O2F2, then here +1 and -1. Remember, dear students, these things are important. Whenever you learn something, that time generally what do you think that कुछ सीखने को मिलेगा, कुछ नया मिलेगा, कुछ पुराना मिलेगा. But whenever you learn something now, that time the curiosity should not end. If you are having curiosity, this curiosity will give you extended form to understand. I have given you few compounds, and this few compounds should knock to your mind. You are really set. Something is special in this compounds by which you can't find the general oxidation state or valency. By using the valency formula, something you should miss. So let's go ahead. As you have seen the things which we have learned, if you want to take a screenshot, then you can take a screenshot of the board. Now we'll move ahead. Hope all of you have taken a screenshot. Now the special thing is what? That you should remember a few points of this chapter. Why you should remember a few points? Because these few points will help you. I am giving you one question. That can you tell me any compound of fluorine in which it exists as not as -1 ऑक्सीडेशन स्टेट? कोई भी ऐसा कंपाउंड आप फ्लोरीन का बताओ जिसमें -1 ऑक्सीडेशन स्टेट वो एग्जिस्ट नहीं करता हो, जितने भी। आपको ये बताना है फ्लोरीन का कोई भी ऐसा कंपाउंड जिसमें फ्लोरीन का ऑक्सीडेशन नंबर या ऑक्सीडेशन स्टेट जो है -1 में है। कोई भी कंपाउंड, इफ आई टॉक अबाउट एनी कंपाउंड, you are taking any compound, remember the sum of their oxidation state should be 0. Just suppose if I talk about sodium sulfate, Na2SO4, this is the compound, right? 3 elements are there: sodium, sulfur, oxygen. You know generally oxygen exists in the -2 form, so there are total here 4 oxygen, so -2 into 4, that is equal to -8, right? -8 oxidation state. Now sodium generally exists in the +1, so there are 2 sodium, the +2, and if I want to calculate here sulfur oxidation state, so +2 of sodium, X of sulfur, and -2 4s are -8 is equal to 0. So you can see here X minus 6 is equal to 0, X is equal to +6. So sulfur exists here as a +6. What I mean to say, in any compound the sum of their oxidation state should be 0. How much? 0. That's why I written here 0. If you want to calculate any compound, in that compound, in any compounds, any element's oxidation state, then you can use this formula and you can calculate it. The words you should remember is the general oxidation state or valency of, just like hydrogen, sodium, oxygen, fluorine, chlorine, bromine. General valency you should remember that chlorine exists in -1. All the 17th group generally exists in -1 oxidation state. All the 16th group element exist in the -2 oxidation state. 15th group exists in the -3 oxidation state. So similarly you should remember these things, the general ones, okay? In any compound, the sum of all the elements oxidation state should be 0. By this way you can calculate the oxidation number or oxidation state. So you can say the algebraic sum of oxidation number of all the atoms in a compound is 0, right? And if polyatomic, that is Stokes notation, remember dear student, if I talk about sulfate 2 minus, SO4 2 minus. So if I want to calculate any element's oxidation state, then it must be equal to this valence, this whatever the notation is given here, Stokes notation. Means if I want to calculate here sulfur, so X oxygen is -2 into 4, which should be equal to -2. So whatever the Stokes notation is given in the compound, it must be equal to that compound. Got it? So as for example, you can see here X minus 8 is equal to -2, X is equal to -2 plus 8, X is equal to +6. So here also sulfur exists in the +6 oxidation state. In any compound, if you want to calculate the oxidation state of any element, then you can use this formula. Just remember that if any notation is not there, any Stokes notation is not there, it will be equal to 0, and if the Stokes notation is there, then it will be equal to that number. Now in the 12th standard or maximum time, you will see that oxidation states are written in the Roman number. Have you heard? Roman number. Now you can say, sir, what is this Roman number? Just I am talking about aurum chloride, AuCl. So here you will see that in the Roman number this 1 is written. This 1 is written in this gold chloride. So this is written here. This indicates that here gold exists in the +1 oxidation state. So when this Roman number indication is given in any compound, then remember Before that, whatever the elements are present, it is the oxidation state of that element. If it is having a double salt, it is having a coordination complex, so that time we'll write. In the 12th standard, especially, I have many times told you, in the 12th standard there will be one chapter called coordination complex. In that chapter we'll learn that how this oxidation state we have to write. Now the most important thing which I want to tell you is oxidation and reduction, and oxidizing agent and reducing agent. Now, what we have learned about the oxidation and what you have learned about the reduction and what you have learned about these two things, and I will teach you now oxidizing agent and reducing agent. First of all, tell me about oxidation and reduction. Whatever the things you have learned, I hope all of you have learned that an increase in the oxidation number is called oxidation. An increase in the oxidation number or oxidation state. An increase in the oxidation number is called oxidation, and a decrease in the oxidation number is called reduction. Can we write like this or not? Right? Can we write like this? Oxidation is an increase in the oxidation number, and reduction means a decrease in the oxidation number. Now tell me about the oxidizing agent and reducing agent. A reagent which can increase the oxidation number of an element in a given substance, so this reagent are called oxidants, and also reducing agent. And a reagent which lower the oxidation state, lower means to do less of an element in a given substance, these reagents are called reductants or redox reactions. So now the two things which you should remember: oxidizing agent means a reduction, and reducing agent means oxidation. Oxidation means increase in oxidation number, increase, losing of electrons, and reduction means decrease in oxidation state. Whatever the oxidation state, as for example -3 was there, so now -4. -4 is less than -3, so decrease. When there is a decrease, it lowers the oxidation number, that is the oxidizing agent. And when it extends the oxidation number in a given substance or in a complex, that is the reducing agent. Any substance, any catalyst which do this work, either if I talk about lithium aluminum hydride, this is called a reducing agent. Lithium aluminum hydride, this is a compound, this is a catalyst, you can say, not a compound, it is a catalyst in which when it goes in the reaction, when especially we will study about the organic chemistry, that time we will learn that what is the uses of this reducing agent and what is the uses of oxidizing agent. These are the catalysts which increases the oxidation states. Increases the oxidation state means from +2 to +3 means losing of electrons, or you can say the increase in the oxidation number. So that's called reducing agent and oxidizing agent. So maximum time students get confused in the oxidizing agent means they understand oxidation, and reducing agent means they understand reduction. So no, never get confused in these two words, oxidizing agent and reducing agent. So whenever anybody will ask you oxidizing agent or reducing agent, oxidation or reduction, so never get confused about this. Now redox reaction, I hope all of you have understand. Reaction which involve change in oxidation number of the interacting species is called redox reaction. And compound, any element is there in which they try to change their oxidation states, either from the reactant side to product side or product side to reactant side. then you understand that this reaction means both the things should occur, oxidation also and reduction also. Now the main thing is what? Now you have to learn about how to balance the redox reaction. This thing I will discuss in the next video. Till yet, this was the introduction of redox reaction. If you are having any doubt related to this, whatever the things I have taught you, I hope you should not have a doubt. But then also if you are having a doubt, then please drop it down into the comment box section. That's all for today. Thank you very much. If you have not liked and subscribed my channel, then don't forget to like and subscribe. To get updates, press the bell icon for the latest notification. That's all for today. Thank you very much.